Hello, my name is Amit Panchal,
And I'm Omar Uslu.
and our project is the effect of propeller design on the velocity of a submersible.
In recent years, we've noticed that underwater research has seen an increase in interest, meaning that the usage of underwater robots have had an increase in prevalence. In order to facilitate efficient motion of submersibles, we are testing the effectiveness of propeller design on velocity.
Our hypothesis is that if the helicoil propeller is tested against the paddle wheel and the screw propeller, then the helicoil propeller will be the most effective in moving the ROV the fastest. Because of its large compared to surface area, it can displace the most water and thus will generate the most velocity.
Through our background research, we found that the three most commonly used propeller designs in commercial applications were the screw, helicoid, and paddle wheel propellers. Though modern propeller theory heavily relies on computer models and simulations, we wanted to test them for ourselves.
Our materials were pretty basic, consisting of mainly PVC pipe, stuff to join PVC pipes together, and a bunch of electronic components. The frame of our ROV was constructed of PVC pipe that was screwed together, epoxied together, and then coated with rubber undercoating to make sure no water gets through. A motor mount was constructed and put on top of the frame, and then pool noodles were added to make sure buoyancy was reached. The brains behind our robot is an Arduino. Originally, we were going to power the motors through the Arduino, but we soon realized that the maximum voltage output by an Arduino is 5 volts. So what we did is power the motors using an external 9-volt battery. In order to ensure consistency throughout our trials, we connected the battery and motors to motor drivers that are capable of controlling the speed of the motors. How we utilized this capability of the motor drivers was by setting the speed of the motor slightly less than its maximum potential. So even if the voltage of the external battery decreases, the speed of the motors would be constant.
On the left here, we can see the propellers that we use, and on the right is the assembly that we use to test our code.
Our data tables were quite distinct. We had 3 data tables showing the performance of each propeller in each trial, and then we had 1 data table showing the average of all the propellers after every trial. This graph shows the average, and this graph shows the performance of each propeller in each trial.
Our results show that the helicoid propeller was faster in terms of speed, but only marginally in comparison to the screw propeller. Though the helicoid propeller was only marginally faster, we believe that since we use such small propellers, with the large propellers used in commercial, military, and research vessels, this difference would increase. However, because of the expense of producing the helicoid propeller, a cost-benefit must be made to see if the extra velocity would actually be worth the cost. Thank you very much for listening to our presentation. I'm Omar.
And I'm Amit.